In our last lesson, we saw how to factor quadratics, as well as polynomials that behaved like quadratics. In this lesson, we're going to take that knowledge and extend it out a little bit into solving. So we're going to start by solving quadratics, which is something we've done before. So since we have done this, take a moment, write down each of these two problems, and actually solve it on your own paper first. Then resume the video and follow along and see how we go and do this to make sure you're on the right track. All right, so in order to solve these, we're going to factor them. So step one is to factor each of these. So for our first one here, that means I'm adding to 3 and multiplying to negative 28. That's going to be an x plus 7 and an x minus 4. Now, one thing I often see is people leave it like this, but that is not correct right now. It still has to be equal to 0, and that's an important point. Because if it's not set equal to 0, we can't really do it from there. Because our next step is to take each of these two sets of parentheses and set them equal to 0. So I do x plus 7 equals 0 and solve that. So subtract 7 from both sides. And so we find that x equals a negative 7. So that's one solution. The other solution comes from doing x minus 4 equals 0. And so I add 4 to both sides of that one. And we end up with x equals 4. So those are our two solutions there for that first one. X equals negative 7 and 4. We're going to repeat the same process now for the second. So step one, factor it. So when I factor this one, I still have the 0 in there, remember. And in this one, I'm multiplying to negative 36, but I'm adding to 0. Because remember, that x term is gone, so that means we add to 0. So thinking about the different ways to multiply to 36, it's got to be a negative 6 and a positive 6. And now, to finish solving it, I set each of those equal to 0. So I go 0 equals x minus 6, and I solve that. So that means adding 6 to both sides. So 6 equals x. And for the other one, 0 equals x plus 6. So there I'm going to subtract 6 from both sides. So negative 6 equals x. So in this second problem then, x equals both 6 and negative 6. Now we're going to extend that solving technique to problems like we were factoring yesterday. So notice each of these, we start with x to the 4th. So going back to that work that we just learned yesterday, that means that when I factor it, instead of each parenthesis starting with x like it does when I have a quadratic, each parenthesis is instead going to start with x squared. Now I see what adds to the negative 26 and multiplies to 25. Well, that gives us a negative 1 and a negative 25. Now I look at each of those parentheses and see, can each of those factor? So the x squared minus 1, does that factor? Yes, it does. The x squared minus 1 is going to factor down, so we go 0 equals still, keep track of the 0. Adding to 0 and multiplying to negative 1 here is going to be 1 and negative 1. So that's the x squared minus 1 factored. How about the x squared minus 25? Does that factor? Yes, it does. Because it's, again, x squared minus a perfect square. Anytime you have x squared minus a perfect square, it's going to be factorable. In this case, it's going to be 5 and negative 5. All right, so now that I've factored it all the way down, because notice none of those can factor any further, now I say solving. How do I solve each of those? And so I would do x plus 1 equals 0 and solve that. So we actually do x plus 1 equals 0, subtract the 1 from both sides, which gives me x equals negative 1. Okay, so there's that solution. I got to do the same thing for each of these. That's going to be a lot of work. But it goes pretty quick because we can kind of see where it's going right away. So like if x minus 1 equals 0, that means I have to add 1 to both sides. So there x would equal a positive 1. If we have x plus 5 equals 0, well, that means I would have to subtract 5 from both sides. So x equals negative 5. And for the x minus 5, I'd have to add 5 to both sides. So there x would equal 5. So in this problem, there's actually 4 solutions. X equals negative 1, 1, negative 5, and 5. So basically, it's the same stuff we were doing with quadratics, but kind of like it's on steroids here. It's really pumped up, really a lot more of the same. All right, so let's go on to that second problem now. We're going to do x to the fourth plus x squared minus 20. Step one is to factor, and so I'm going to want to figure out what adds to a positive 1 in the middle and multiplies to a negative 20 at the end, and that's going to be equal to 0. So adding to 1 and multiplying to a negative 20, that's got to be a plus 5 and a minus 4. Now I look at each of those and I see, can they factor? The x squared plus 5, that does not factor because it's not x squared minus a perfect square. So that part, it's going to stay the same, so x squared plus 5. However, the x squared minus 4, that does factor because it is minus a perfect square. Anytime it's minus a perfect square, we know it's plus and it's minus. That's why it's got to be a negative that we multiply to. And multiplying to 4 is 2 and negative 2. All right, so now we need to solve. Well, the x plus 2 and the x minus 2, those are simple enough to solve. We do those like we did the last problem. If we have x plus 2 equals 0, I subtract 2 from both sides, x equals a negative 2 there. For the x minus 2, I add 2 to both sides. So there, I'm going to end up with x equals a positive 2. But what about the x squared plus 5? Well, the x squared plus 5, because it does not factor past that, that's actually as good as it gets, so there's no solutions from that. So in this particular problem, we would only say that x equals a negative 2 and a positive 2. That's it, nothing else. The one that does not factor, we say there's no solutions from that particular one. All right, now we're going to practice that idea even further with these two. So let's see how well you've got it so far on your own. So go ahead and write down each of these two problems, and then try to solve them on your own, and then resume the video here so you can see how well you're doing. All right, so our first one, we got to factor it first, of course, because we always start by factoring. Because it's x to the 6th and x cubed, that means that both parentheses start with x cubed. And then I need to add to 6 and multiply to a negative 40. That's going to be a positive 10 and a negative 4. So then I take a look at each of those and I say, can I factor them? Well, the first one, definitely not. X cubed plus 10, definitely no, cannot factor it. But the second one, x cubed minus 4, it is minus a perfect square. But it's x cubed, not x squared. So actually that one does not factor either. So this is the final answer. Well, there are ways we could get decimal solutions and all that. We aren't going to be worrying about that right now. This one would actually give us no solutions right now. So we're just going to call that one done. There's no solution from that. All right, now on to the second one. Again, we got to start by factoring it. When I factor this one, of course, both parentheses start with x squared. Because it's x to the 4th, then x squared. And there, I'm adding to negative 14, multiplying to 45. That would be a negative 5 and a negative 9. So now I look at each of those and I say, can those factor? The x squared minus 5, it does not factor. It is x squared and it is minus, but it is minus 5, which is not a perfect square, so no. But the x squared minus 9, that will factor. So we're going to put in another line. The x squared minus 5 stayed the same, but then I'm going to factor the x squared minus 9. So that's going to be x minus 3 times x plus 3. And now each of them that I was able to factor all the way down, I can solve. So the x squared minus 5, couldn't factor it, so I leave it. The x minus 3, I can solve that one. And the x plus 3, I can solve that one. The x minus 3, that gives me an answer of a positive 3. The x plus 3, that gives me an answer of negative 3. Because those are the things that I could plug in that would make it equal 0 over here. And so then that's our final answer, x equals 3 and negative 3 for that.